So today and tomorrow we are going to look at equations that have three variables. Our process is the same. We still have substitution and elimination as options, but it's going to be a little more work to get to the end. If you have three variables, in order to get a solution, we have to have three equations. So we will have more things to work with as we go through. So here is our first example. Okay, we have x's, y's, and z's. So give me a second to write this down before I start.
Is it the same methods? Wait, how would it work with elimination? Would like negative r for negative one, like stop.
Okay, so our answer here will be not just an ordered pair, an ordered triplet in this case. We'll have an x, a y, and a z. When you have variables, just put them in alphabetical order when we write them. Whatever numbers we get here should make all three equations true. So when I go to solve these, what we're going to do is take two equations at a time, and we are going to eliminate one variable. Okay, it doesn't matter which two equations and which variable, we're just starting somewhere. So let's say I took the first two equations. What variable do you want to eliminate? X?
Yeah.
Alright. So to eliminate x, what would I have to do? Take the top equation times -4. If you're eliminating y, you take the top equation times 3. If you're eliminating z, you take the top equation times 2. I'm going to change the second equation. So when I add those together, I get -7y 6z equals 20. Right, now, we have not used the third equation yet. So I have to take the third equation and one of the other two, doesn't matter which, but I have to eliminate the same variable. So since I got rid of x here, I have to get rid of x again. So which equation do you want to pair it with? Top one? Okay, in order to get rid of x, what would you have to do to the top? At this point, we have two equations, and both of these have two variables. So this is kind of where we were starting last week. If I wanted to put those together and eliminate something, what would I do? Okay, I could take this one times 6. So I didn't change the first equation. Put these together. so now I know my y. What would we do with that? Okay, so either of these equations highlighted in yellow, we can plug it in if I just go with the first. So -7 times -2 is 60 equals 20. So my z is 1. And now I have y and z. So go back to one of the beginning equations to get x. So the first one, x plus y, which was -2, minus z, which was +1. And you can check these just by plugging them into the original equations. So our x was 2, y was -2, and z is 1. Okay, 2 times 2, 4, plus 4 is 8, minus 3 is 5. 8 plus 6 is 14, plus 2 is 16. 2 minus 2 minus 1 is -1. So it checks, it makes all of them true. So the process is longer. Basically, the first thing, these first two eliminations, that's the new piece that we added. So you have to take two equations at a time, eliminate the same variable in both of those. Once you get to that point, you have two variables remaining, so then it's like the old problems. Any questions? Let's practice some. Let's do this one. Okay. What do you notice? The bottom one doesn't have z. So you can still take two equations and eliminate a variable, but since I noticed this one doesn't have z, I would prefer to get rid of z in the first instance. So if I did that, we don't even have to multiply by anything, do we? Again, you don't have to do it this way, but it will save us some steps if we do. Those z's drop. And then notice, we have two equations, and neither one has a z, so can't I go ahead and put those together? Okay, so let's just take one of them times the -1. So I'm going to add those together, both my x's and y's cancel, so I get 0 equals 3. So what do we write? No solution, inconsistent. Let's try another.
Oh, there
I'm gonna wait for that. Yeah, I'm jumping around.
Ready for it.
So what do you want to get rid of?
Do Y's and latitude.
Okay. So if I take the bottom two, I can eliminate y without doing anything extra. I just have to put them together. So 2x plus 2z equals 10. Okay, for the next one, which equation do I have to use? Top one, because we haven't used it yet. What variable do we have to eliminate? Y, because we got rid of y the first time. So which equation do you want to pair it with? Okay. 5x plus 2z equals 18. So now I need to put these two together and eliminate a variable. How could you do that? Okay, if you take the first one times -1. So 3x equals 8, so x is 8/3. And we know we can have fractions on these, so that's okay. So now we have to work backwards. We have x, plug it back into one of these equations. Um, 18 So you get 7/3 for your z. And you have x and z, so we need y. You can go back to the beginning and plug it in. So I'm going to do the middle one. So -x plus y plus z equals 1. And did you get 4/3 for y?
No.
Yes.
I'll take your word for it.
When you put them, you go x, y, z. You can always check them by plugging them into the original equations. If you were working it on your own and didn't get that and you may look at something, let me know. Okay, I told you if you had 3 variables, you would have to have 3 equations in order to be able to solve it. You notice this one has 3 variables, but only 2 equations.
So you
So-
lying to us now?
We are not going to get a number solution. Remember some of those where we had to write it in terms of x or y, so your final answer was an order pair that still had x's or y's in it? That's what's going to happen here. Now, I'm telling you to solve it in terms of x. So that's like saying x is arbitrary. So the x stays. You have to figure out what y and z are, but the only variable we can use is x.
Okay.
Could we, looking at these, which equation do you think would be easier to start with? The bottom one. Could you solve for y right here, get the y by itself?
Yeah.
So if you subtract that 2x over y is 4 minus 2x. That's in terms of x. So now we have our y. So now we can substitute that into the first equation. We're going to keep the x minus 2 times the y is 4 minus 2x plus 3z equals 7. What am I trying to solve for here? Z. Gotta get that z by itself. Okay. Oops. So the x, we have to distribute the negative 2 here, so minus 8 plus 4x. I'm going to add over my 8, subtract my 5x. So z is, you could write it a couple different ways. You could say 15 minus 5x all over 3, or 15 divided by 3 is 5, minus 5/3 x. It doesn't matter which one you write. So that gives us our answer. X is x, y is 4 minus 2x, and z is this. Questions here? So, today we are actually going to stop here. I'm not completely done. Like, I've shown you how to do them all, but I might do a word problem or two tomorrow. There is a Math Excel assignment. I think like the last 2 questions maybe are word problems, so you could wait until tomorrow to do those. But you're ready to do everything else. So there's only 7 questions. You'll notice it's not due until Wednesday because we're still working on this tomorrow.
You said Wednesday?
Doing a little more
So I
practice.
want to start tomorrow.
Yeah, start right now.